Hi, it's Miss House. In this lesson, I'm going to talk with you about two things: graphing lines and slope. So I'm going to just go over a few basic things first, and then I'm going to do a bunch of examples for you. So if we have a line drawn in a coordinate plane, as you know, you have an x-axis and a y-axis. Every line is going to have a characteristic called its slope, and that's how steep or flat a line is. There are four basic kinds of slope that you need to be able to recognize just from looking at the graph, and we're always going to look from left to right. So for example, this first line I've drawn has a positive slope, and that's because it's going uphill or rising from left to right. That's considered a positive slope. Now, when we have a line that goes downhill from left to right, same thing, we got our X and Y plane, and we have a line that's going downhill from left to right. That is considered a negative slope. So a negative slope is going downhill, or we can describe that as falling from left to right. Now, most lines will have either a positive or a negative slope, but there are two other unique kinds of lines. Beyond these two kinds, and that is the first kind, which is a horizontal line. So this is horizontal, and it has a zero, that is the actual number, zero slope. Okay, so it's completely flat. And the last kind is going to be a vertical line. And this has what we consider to be an undefined slope. So let's talk about why a slope can be positive, negative, horizontal, zero or undefined. So slope is defined to be the ratio of rise to run from one point to any other point on the line. So we say slope is rise over run. And M is the letter that we use for slope. So when we have a formula for slope, we'll use M. Now, rise is the distance from one point to the next in the y direction, right? Remember, the y-axis is the vertical axis, so you're going up or down on the y, and then this is the x direction. So, for example, sketch a line here. I'm going to pick a couple of points. So let's say I have a point at 1, 1. So that's 1 on the x and 1 on the y. and a point at 5, 5. So over 5, up 5. If we were to measure how far we have to go up, that is in the y direction, that would be 4 spaces. And then we would measure how far we went over, that's to the right. That's also 4 spaces, because from 1 to 5 would be 4 spaces. And so our slope would be 4 over 4, which can also be reduced to 1. So in other words, if I have a line here between these 2 points, I can go up 4 over 4, or I can go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And I'm going to be on that same line. And no matter where I am on this line, because it's a straight line, that ratio is always going to be 1 to 1, or 4 over 4. We could even go 3 to 3, anything that's equivalent to 1. Now we can do this by graphing the points and counting, or we can use the slope formula. So here's our first formula. It is y sub 2, and that just means the second y, minus y sub 1, the first y, over x sub 2 minus x sub 1. And again, those are not exponents, those are subscripts. So we say y sub 2 minus y sub 1, or you can say y number 2 minus y number 1. So I could have done this one by the formula. 5 minus 1 over 5 minus 1, and I would get the same answer, and I wouldn't have to have the graph if I had the 2 points. Now, when you're doing horizontal and vertical, okay, the slope of a horizontal you're going to get a slope of 0 over some other real number. And anytime you divide into 0, the answer is 0, okay? 0 divided by any number is 0. And the slope of a vertical, any vertical line, is going to be some real number divided by 0, which is undefined. Division by 0 is undefined. So let's do some examples of finding slope and of graphing some lines. We'll talk a little bit more about the graphing lines when we get to some of the problems. So the first thing you're going to do is look at a line, and you're going to describe its slope as either positive uphill, negative downhill, 0 if it's flat or horizontal, or undefined if it's vertical. So this line's going down the hill from left to right, so this is a negative slope. Okay, now yours will be different, possibly, okay, because the problems in my math lab are algorithmically generated. So we're going to find the slope of this line if it exists. Well, this line, I could just count my rise and run, but look, it's going downhill. And since it's going downhill, I know for sure my answer is negative. Okay, so I know my answer is going to be a negative. I count the spaces down, 1, 2, 3, so that's down 3, and the spaces over, 1, 2, so my slope is negative 3 over 2. So I'm counting the rise over the run, but the rise in this case happens to be a fall, so that's why it's a negative. Here I notice in number 3 that I have a vertical line. So the slope of a vertical line is undefined. It doesn't matter where the vertical line is located, because look, I can count the rise. Here the rise is 6, but it doesn't move at all from left to right, so that's a 0 denominator. And a 0 denominator is always undefined. In example 4, I'm going to find the slope of the line, and instead of drawing the graph, I'm going to use my formula. Now, I'm going to go ahead and mark these x1, y1, x2, y2. Now, be careful with your formula. Always go ahead and put those two subtractions. That way, if you've got a double negative, you won't forget that there's a subtraction in the middle. So this one is going to be the second y, negative 9, minus the first y, look, negative 3. So it's important that I know I'll have a subtract in the middle there. My denominator is my x2 minus x1, so that's a negative 7, subtract a negative 4. Now, whenever you have subtract a negative or a double negative, those are going to be positives. So I have negative 9 plus 3 over negative 7 plus 4. And I've got to be careful with my arithmetic here. When I add a negative and a positive, I actually subtract, and I have more negatives, so that's going to be a negative. When I add a negative and a positive here, I'm going to subtract, that's a 3, and more negatives, so that's a negative. And now a negative divided by a negative is a positive. So the slope here is 2. Example 5. Find the slope of the line through these points. So again, I'm going to do my slope formula. I'm going to draw my fraction with my two minus signs. I'm going to take my second y, negative 9, minus my first y, negative 4. There's that double negative again, so that's going to be a plus. My denominator, negative 1, subtract negative 1, and look, double negative is a plus. In the numerator, a negative 9 plus 4 is going to be negative 5. But this time in my denominator, a negative 1 plus 1 is 0. So this slope is going to be undefined. Example 6. Following through with my formula, I'm going to put a minus and a minus. So I'm going to get an 8 minus 9 and a negative 5 minus negative 8. My double negative becomes a positive. My numerator is negative 1. 8 subtract 9. You've got to be 1 in the whole. And then my denominator is negative 5 plus 8. That's a 3. So this time my slope is negative 1/3. Example 7. Find the slope of the line through these points. So my slope formula again, minus on top, minus on bottom, 2 minus 2 over negative 4 minus 8. That's going to be 0 over negative 12, and that's a 0. The 0 in the numerator, when you divide, ends up being 0. It's in the denominator when it's undefined. So here, our slope is 0. Now, in example 8, we have the first example where we're given the equation of the line, and we could graph that line by finding points on the line, but we haven't done that yet. So what we're going to do is we're going to learn to recognize this format of the formula, and this is called the slope intercept formula. And that is y equals mx plus b. And that plus could be a plus or a minus. In this case, it's a minus. In this format, m is your slope. It's right there. We don't have to do any work to find our slope. So our slope here is a 2. So when the equation is solved for y, notice I have a y on this side all by itself. The slope is going to be the coefficient, that is the number in front of or multiplied times x. That's where our slope is, so it's very easy to find. So in example 9, to find the slope, we don't have to do a lot of work. It's just this number in front of x. Now, it's not the x, so don't put the x in your answer. It's just the number, negative 0.3. Example 10, find the slope of this line. Now, this line is not in the slope-intercept form. It's in what we call the standard form. Standard form of a line. And that's where you have a times x plus b times y equals c. And again, this could be a minus or a plus. Okay? So let's take the time to solve ax plus by equals c. I'm going to solve it for y, because remember, if I can get it into the y equals mx plus b form, I'm going to be able to find the slope very easily. So the first thing I'm going to do is I'm going to subtract an ax from both sides. It's okay that it's not a number. Okay, it's still something that I can subtract because it's being added. That's going to give me by equals, and I'm going to put the negative ax in the front, plus c. And now the only thing I have to do to get it in this format of y equals mx plus b is to get rid of this b that's being multiplied. So I'm going to divide every term by b. So y is the opposite of a over b. Use the word opposite, not negative. Okay, it makes it easier. Plus c over b. So if I solve this one for y, 9x minus 7y equals 63, I would go through this exact same process. Or I could say, hey, this is in standard form, and my slope is the opposite of a over b. So my slope is the opposite of 9, which is negative 9, and b is negative 7. So a negative divided by a negative is a positive 9/7. My slope is 9 over 7. So in standard form, we have the slope is the opposite of a over b. Or you could go through the actual steps of solving the equation for y. So here I have a slope of the opposite of a. So the opposite of negative 5 is 5 over exactly b, which is negative 9. So my slope is negative 5/9. Now, when we have a negative in the denominator, it's best to either write it in the numerator or write it even with the bar. Okay, we won't leave it in the denominator. That's not usual. Okay, that's not customary. If you do it, that's fine. It won't be counted wrong. But there's some reasons later on you'll see where when you start moving minus signs around, you got to be careful. Even with the bar is the safest place to put the negative.